are you tonight?
I'm good. How are you?
Good. Okay, shall we start with A here?
Yeah.
Okay, it looks like you did it correctly. In
Yeah.
other words, when you're multiplying, you add exponents.
Mhm.
When you are exponentiating, which is what this is called on D, apparently we're going left to right instead of up and down. That's fine.
Yeah, I do that
Okay,
usually.
I understand it. Same way. Um, so when we're exponentiating, we do multiplication of the exponents. One way that I think about that is if I am multiplying, I am going to do one level less addition.
Mhm.
If I am dividing, I am going to do one level less, which is subtraction. Do you see how subtraction is one mathematical less than division?
Yeah.
Okay, and same with exponentiation. If I am exponentiating, then I am going to do one level less, which is multiplication. And that's the way I remember those rules.
Mhm.
Now, the parentheses make all the difference in the world here. There is a difference between these two expressions. In the bottom expression, the cube only applies to the x. It does not apply to the 3. In the top expression, the cube applies to the 3. So we have to cube 3 also. In other words, this thing is equal to 3 cubed times x cubed, whereas this one is equal to 3 times x cubed. So what's 3 cubed? 3 times 3 times 3. What is it?
Oh, that would be 9.
27. So G should be 27x cubed.
Okay.
Let's keep going left to right. I got no problem with that. What does a negative exponent mean?
I don't really remember.
It doesn't have anything to do with negative numbers. Most people cannot get away from that thought that it has to be a negative number. It does not. Because all it means is the reciprocal. Okay? In other words, 2 to the minus 1 would be equal to 1 over 2 to the positive 1, or 1/2. And in fact, most of the time, it does not equal a negative number. It equals a positive number, almost always, unless x is negative.
Okay.
Okay? All right, what's B? Excuse me.
Um, wouldn't you have to multiply the 10 and negative 6?
No, remember, multiplication is what is taking place on the base. I'm multiplying
Okay.
y to some exponent times y to another exponent. So what I have to do with the exponents is always one level less than multiplication. The same thing
So
we
you
did
would
up
be
in A. We added the exponents.
okay.
So what's the answer on B?
Y to the 4th?
Correct. How about E? E, we have 4x plus 2 cubed and then the whole thing taken to the fourth power. Well, what's the first thing you'd do?
You would multiply the
Right,
exponent?
right. We have here what is called exponentiation, or what I even call double exponentiation. So we're going to multiply the exponents. So our answer is going to be that. And we don't have to multiply that out. In other words, that's the proper answer. The wrong way to do this would be to cube this, doing all of the arithmetic required to cube that, and then taking it to the fourth power. That would be not what they're looking for. All right. About H. What is 5/3? Give it to me the way I taught it just a moment ago. One over what?
1 over 5/3.
To the positive 2. In other words, every time you see a negative exponent, you make it 1 over that thing to the positive exponent. Get it?
Mm-hmm.
Okay, now let's simplify that. In this case, we can simplify it because it's easy enough to do. What's 5/3 squared? Square the numerator, square the denominator.
25 over 9.
And now simplify that. How do I simplify that? Where I have a fraction in the denominator.
Wouldn't you?
Invert it and multiply.
Yeah.
So, 1 over 25/9 is the same as 1 times 9/25, or just 9/25.
Okay.
Okay? All right, let's look at K. Now, let's talk about this situation. If I had 1 over 2 to the minus 3, whenever I have a negative exponent, as long as I move the whole thing to the other side of the fraction bar, that's the same as that. In the same way that 2 to the negative 3 is the same as 1 over 2 to the positive 3. Okay, so whenever you see a negative exponent, you can just move the entire thing above the fraction bar and change it to a positive exponent. Okay, understand?
Okay.
Okay.
Yeah.
So this problem right here, we have everything under the fraction bar, but one of it has a negative exponent. And usually with problems like this, they say do not leave your answer with any negative exponents. They want positive exponents only. So what does this turn into?
AX. Wait.
No, the negative 3 only applies to the x. It does not apply to the 8.
Okay. Wouldn't you have to combine the exponents first?
No, these are different variables. You can only combine exponents if the base is the same. In other words, as long as I have as long as I have 7 to the 3rd times 7 to the 5th, that's 7 to the 8th. I can do that.
Okay.
But if I have 6 to the 3rd times 7 to the 4th, I can't do anything.
Mm-hmm.
The only time you can combine them is if the base is the same. Okay? So the base isn't the same with any of these. We have three different things. We have a number, we have a variable, we have a different variable. So the only thing we can do is move stuff to the other side of the fraction bar if it's required. So what goes to the numerator?
8.
No, it doesn't have a negative exponent.
So that would be the x.
The 8 stays down there, but the x to the third, see, the x is to the minus third, but it's in the denominator. I want to make it a positive, so I move it to the numerator. That's all there is to it. And then the y to the fifth is already a positive exponent, so there's the answer. It's very simple, actually. Okay. Now in this case, number C, notice that we have the same base. All three are A.
Mm-hmm.
So what's the answer going to be?
A. Wouldn't that be 0? It'd just be A.
Well, A to the 1 is A. A to the 0 is what? Any number to the 0 power is 1.
Okay.
And I mean that. 100 to the 0 power is 1. 1,000,000 to the 0 power is 1. Guess what? 0 to the 0 power is 1. Minus 10 to the 0 power is 1. So it doesn't matter what A is. If A is taken to the 0 power, it's 1. Okay, on F, what's F going to be?
X to the negative 10th.
You got it. How about I? What order are we going to do things in?
Multiplicate, or the exponents?
Do the exponents first. So this part here, that's r to the fourth, s to the third, t to the sixth cubed, what does that become? We'll take them one at a time. We're doing double exponentiation, so what do we do to the exponents?
So would it be r to the 12th, s to the 9th, and t to the 18th?
That's the first part.
Okay.
The second part, do the same thing.
R to the 12th and t to the 4th.
Now, as all we have is same bases being multiplied, so what now?
You would combine like terms.
Hold on. Let's handle each variable separately. What's r to the 12th times r to the 12th?
R to 144.
R to the 24th.
24.
We're not multiplying the exponents because we're multiplying the bases. So always remember you're going to do one level less.
Okay.
Addition is the one level less than multiplication. How about the s's?
It would just be s to the 9th.
And the t's?
That would be 22.
There's your answer right there.
Okay.
So do exponent. It's kind of similar to PEMDAS, if you remember PEMDAS. Do your exponentiation first, then do the rest of it. How about L? What is this equal to? give you a hint. It's got a fraction.
Wouldn't it be t to the fourth over 10?
Got it opposite.
If,
In other words, this part here becomes t to the fourth down there.
oh, okay.
The 10 stays where it's at. In other words, this minus 4 is not operating on the 10. There's no parentheses around that. This is not the same expression as this would be. This, the 10 would be operated on by that minus 4 also. So the lower one would be 1 over 10t to the fourth. Like that. So the parentheses are big in these. The parentheses tells you what the exponent is operating on. And if there aren't any parentheses, then the exponent is only operating on the thing that it's next to.
Okay.
M, scientific notation. How would I write that first number?
Oh, I remember this a little bit. So it would be 2.69 times 10 to the 6th. So that would have...
What is 10 to the 6th? First of all, what's 10 to the 1?
100.
No, 10 to the 1 is 10.
10, sorry.
10 to the 2 is what?
100.
Okay, so what can we see is going on here? What does that exponent equal?
The amount of zeros there are.
Okay, so let's write 6 zeros following that. So 10 to the 6th is 1,000,000.
Mm-hmm.
So what's 2.69 times 1,000,000?
Wait. 2.
What's 2 times 1,000,000?
2 million.
Okay, so what's 2.69 times 1,000,000?
2,690,000,000.
269, 2,690,000, like that.
Yeah.
Okay. On n, what is 10 to the minus 1 equal to?
0.1.
Okay, 0.1. I don't ever feel the need to write that leading 0. I'm not quite sure why they teach it that way, where all of my students give me that leading 0. Well, I leave it out because it's not needed. Okay, what's 10 to the minus 2 equal?
Would it 0.734?
0.01, just 10 to the minus 2.
Yeah.
Okay, and now what is 7.34 times 10 to the minus 2?
0.734.
Yeah, it's going to be 7 point, no? How much bigger is 7 than 1? In other words, this first expression here is 1 times 10 to the minus 2.
Mm-hmm.
So 7 times 10 to the minus 2 would be what? Let's just do it one at a time. Okay, what's 7 times 10 to the minus 2?
0.07?
Yes. Okay, so 7.34 times 10 to the minus 2 must be what?
0.0734.
Exactly. In other words, the only thing that's really important on these problems is getting your decimal point right. Correct?
Mm-hmm.
We
Yeah.
know it's going to be a 734 somewhere. So we just have to get the decimal point right. Well, to get the decimal point right, forget those two digits and just compare 7 times 1. We know it has to be 7 times bigger. The 0.07 is 7 times bigger than 0.01. Okay. What's 0.1 times 10 to the 0?
Wouldn't that just be 1?
Well, 10 to the 0 is 1. So it becomes 0.1 times 1. Anything times 1 is equal to what?
Itself, so it's
Okay.
0.1.
0.1. All right, so for P, we want to rewrite it as scientific notation. Now, in scientific notation, the only requirement is the first number be between 1 and 10. So what's our first number need to be?
5.
5.342. There's a number between 1 and 10.
Yeah.
Okay.
And then
that's the first part. And then times 10 to the what?
10 to the third.
No. What did we say 10 to the sixth was?
Oh, it would be 10 to the sixth.
10 to the sixth was 1,000,000, right?
Yeah.
Well, isn't this?
No.
Yeah. In other words, isn't that right there the same as this number?
Yeah.
Okay. So I can replace 1,000,000 with the number of zeros there are. That's 10 to the sixth. Okay? Okay. On number Q, what do we want to start it out with? It's got to be a number between 1 and 10.
6.02.
Correct. Now, the question is, first of all, let's review. What is 10 to the minus 2 equal to?
0. And then whatever. Yeah.
So when you have negative exponents, it's that number minus 1 is how many zeros you have. Okay, in other words, 10 to the fifth is going to be 10 to the minus fifth is going to be 4 zeros. Like that. Okay, so if it's positive, it's the number of zeros. If it's negative, it's 1 more than the number of zeros. You with me?
Yeah.
Okay, so 0.01 would be, we just said it was 10 to the minus 2. So what goes here for Q?
10 to the negative fifth.
Negative 2. Notice that our number is 0.0602 is equal to 6.02 times 0.01, right? Well, 0.01 is 10 to the negative 2.
Oh, okay, I see.
Okay? How about R? 2.0. Write it in scientific notation. 2.0 times what?
10 to the 0.
Good. Okay. When you're multiplying or dividing by scientific notation, divide the whole numbers and then divide the second part separately. So we're multiplying here. So multiply the whole numbers. What do you get?
90?
9 times 4. Those are the whole.
Oh, 9 times 4. 36.
Okay. And then add the exponents. In other words, we're multiplying 10 to the minus 4 times 10 to the minus 1.
-8.
Add the exponents.
Oh, wait. Oh, it's 1. It looks like a 4.
Okay, right. I get that. Okay, so this is our answer. There's only one problem. That's not in scientific notation. In other words, we need our answer to start out 3.6. Well, what's my new exponent going to be?
-4?
Good. It's either going to be -6 or -4, right? Okay. Let's take a case that we can figure out. How do I do that problem right there? 12 times 10 to the second. If I want to put that in scientific notation, I know my first number has to be that. Well, how do I figure out which way to go on the exponent?
Whether or not it's positive or negative?
Well, yes, if you can remember that. But let's just figure out what this number is. What is this number? What's 10 to the second?
100.
What's 12 times 100? What's 12 times 100?
1,200.
1,200. Okay. So, what did I do when I moved my decimal point one spot to the left? How many exponents did I have to add to the 2?
1.
Correct. Okay, so that became 1.2 times 10 to the third, right? This number is also 1,200, and that's a vital thing with these scientific notation. It's the same number, it's just a more concise way of expressing it. So, when you move your decimal point to the left, you add to the exponent. Well, to get this 36 times 10 to the minus 5th down to 3.6, I had to move my decimal point one place to the left, right? So I added 1 to the exponent, making it -4.
Okay.
All right. Let's see. How much did we not cover? You want to do one more? Hold on. Let me make sure I have time. Yeah, I do. Okay. Sometimes I have an immediate another session. Sometimes I don't. So we're doing division here. So what do we do with the 5 and the 8?
You subtract them?
You divide. I can understand why you said subtract, but that's when we're dealing with exponents. If we're just dividing, we just divide. In other words, it's 5/8, which happens to also be equal to 0.625 times 10 to the what? Now you subtract the exponents.
-8.
What is -2 minus, remember, we're subtracting the exponents.
Oh, it would be 4.
Okay. Now we got to convert it to scientific notation. What's the first thing that's required? This thing has to be between what and what?
1 and 10.
So what do we have to do to that decimal point?
So it would become 6.25.
So we had to move the decimal point to the right this time, which means what are we going to do to that exponent?
Subtract it, so it becomes 3.
Subtract 1. In other words, when you move the decimal point to the right, you subtract however many spots you move it. If you move it to the left, you add however many spots you move it. And if you forget, in other words, that's something that would be real easy to get mixed up, well, notice that 0.625 times 10 to the 1 equals what? What's 10 to the 1 equal to?
0.1 or 1.
Just 10. 10 to the 1 equals 1. And 10. Anything to the 1 power is equal to itself. And now what's 10 times 0.625?
6.25.
Right. Okay, so if I was going to express that as scientific notation, I know what the number is. So it's 6.25 times what?
0.
Yes. And that always tells you which way to move the decimal point, depending on, whether you're going right or left. In other words, I had to go to the right and I had to subtract. If I'm going to the left, I got to do the opposite. So if you forget something like this, always fall back on a situation that are small numbers that you know exactly what's going on.
Okay.
If this decimal is 13, I don't know what's going on. I got to fall back on my memory. But if it's 1, I know that 10 to the 1 is 10. So this number times 10 has to be this number. Well, if I'm going to express this number in scientific notation, it's 6.25 times 10 to the 0, because 10 to the 0 is 1.
Okay.
All right. I will let you go. Let's see. I think you have another session scheduled. Yeah, for Friday. Pick up on this material, or are you going to send me more? It looks like we got plenty to do.
Yeah, pick up on this material again.
Okay. I won't delete it then. We'll pick up from this spot.
Okay.
All right. Sounds good, Kendall. I will talk to you on Friday.
All right, thank you.